Welcome to Lesson 10, where we tackle the unglamorous but absolutely critical skill of scheduling jobs on Ubuntu. Every production fleet you'll ever touch runs scheduled work. Backups, log rotation, the certbot renewals we set up back in Lesson 7, database vacuums, monitoring checks. Ubuntu gives you two ways to do this. Classic cron, which is everywhere and dead simple, and system timers, the modern replacement with proper journal logging. Over the next 12 slides, we'll cover both, plus the fleet-safe patterns, RandomizedDelaySec and persistent, that keep 1,000 hosts from hammering your backup server at exactly 3 a.m. Let's start with the classic cron. 5 fields: minute, hour, day of month, day of week, then your command. Memorize it once and you've got it for life. For your own scripts, cron tab, E works fine. But in production, you want files in RE, etc., cron.d. They live in version control, ship with your config management, and take an extra user field so root owns the schedule. And the gotcha that bites everyone? Cron runs with a minimal path. Your script in USR local bin won't be found unless you set path explicitly at the top of the cron tab. Always set path. Now system timers, same job, different philosophy. You write 2 files with the same base name. Backup, service says what to run, backup.timer says when. The service is just a normal unit from Lesson 6, with type Irish one-shot because it runs to completion and exits. Notice there's no install section in the service. It's the timer that gets enabled, not the service. And watch that wanted by at the bottom, timers.target, not multi-user.target. Wire it up with systemctl enable, now backup.timer, and you're scheduled. The when part lives in OnCalendar, and this is where system pulls ahead of cron. You get named shortcuts like daily and weekly, explicit calendar dates, day of week ranges like mon fry, and step values like every 15 minutes, all in one consistent grammar. And critically, you can validate before you ship. System to analyze calendar normalizes your expression and shows the next elapsed time. Run it on every pattern before it touches a production box. No more discovering at 3 a.m. that your cron line was off by a field. Now, OnCalendar gets you the timing, but 2 more directives are what make timers fleet safe. RandomizedDelaySec solves the thundering herd. 1,000 hosts firing backup at 03 hour sharp will flatten your backup target or S3 endpoint. Spread them across a 2-hour window and the load smooths out. Pair it with fixed random delay true so each host picks its offset once and sticks with it. Then persistent to true catches missed runs after downtime. Exactly what you want for backups, log rotation, and certbot renewals from Lesson 7. Skip it for liveness checks, where a stale run is meaningless. And OnBootSec handles warm-up tasks 5 minutes after boot, looping hourly with on-unit ActiveSec. So when do you actually reach for each tool? Cron wins on simplicity. 1 cron tab line, runs on any Unix, perfect for a quick script or porting a job from Arhel. But everything else on this matrix tilts toward timers. Journal CTL logging for free. The dependency model and resource limits you already learned in Lesson 6. Built-in randomization, and persistent true to catch up after downtime. The rule of thumb: default to system timers for new Ubuntu work. Keep cron in your back pocket for one-offs and cross-distro scripts. Now, scheduling is only half the job. You also need to know when things break. Start with systemctl list timers, all to see next and last runtimes at a glance. Then check the service itself for exit code 0. For deeper digging, list units, state failed surfaces, anything that crashed, and journal tile you grepped for errors gives you the why. For cron, pipe your script through logger so it lands in the journal alongside everything else. And the real win, wire a Prometheus alert on failed unit state. We'll cover that in Lesson 19, so you get paged before the backup is 5 days stale. So with monitoring in hand, let's look at what an actual production fleet runs. 8 jobs every Ubuntu shop. Database backup at 3 a.m. with 2-hour jitter and persistent true, so a rebooted host still catches up. Log rotate daily via the ancient cron daily hook. Certbot twice a day from LO7, App daily at 6 a.m. with 12 hours of jitter. Snap refresh every 4 hours. Postgres vacuum, weekly Sunday at 2. Prometheus evaluating every 30 seconds internally. And a tiny cron one-liner trending disk usage at 2355. Audit those 3 timer directories monthly. You should always know what's firing on your boxes. And to keep that audit muscle sharp, here's your cheat sheet. Bookmark this one. On the cron side, cron tab -L and -E for your own jobs, -U to peek at another user's, and grep cron and syslog when something's gone quiet. On the timer side, list timers shows you next and last run at a glance. System cat and edit, inspect, and override safely using the L06 drop-in pattern, and system to analyze calendar validates your OnCalendar expression before you commit it. Honestly, list timers plus journal CTL-U on the unit solves 90% of scheduled job debugging on Ubuntu. Memorize those 2. Now the 5 things that have bitten every one of us at least once. Number 1, cron's minimal path. Your AWS or kubectl command works in your shell and dies silently under cron because cron only sees joshesser bin and bin. Set path explicitly at the top of the cron file. Number 2, enabling the service instead of the .timer. The service runs, the timer schedules, always enable. Now on the timer. Number 3, RandomizedDelaySec missing on fleet-wide jobs. 1,000 hosts hitting your backup server at 03 Ogorod sharp will cascade fail. Add 30 minutes of jitter, 2 hours for big fleets. Number 4, missed jobs after reboot without persistent true if the host was off at 03 on. That backup is simply gone. And number 5, cron output going to root's mailbox where nobody looks. Pipe it through logger with a tag, then alert on the journal. Migrate to a system timer and you get that journaling for free. So let's lock in what you can now do. You're fluent in classic cron's 5-field syntax and know, etc. cron.d is where system jobs belong. You write system timer and service pairs, express any schedule in OnCalendar, and validate it with system analyze before it ever ships. You randomize across fleets to kill the thundering herd, use persistent true so missed runs catch up after downtime, and you monitor with list timers and journal CTL-U instead of hoping. Next lesson, we take that journal output and forward it, centralized logging across every host. And that's lesson 10 in the bag. Schedules under control, from cron syntax to fleet-safe timers with proper monitoring. Next up, lesson 11, where we take everything journal CTL has been showing you and scale it across hosts. We'll go deep on journaled persistence and rate limits, forward over RSY slog with TLS, and look at Loki and Promtail for cloud-native fleets. It's the last lesson of stage 02. Then hardening begins. See you there.